This video is for dividing polynomials using a table. So we're going to do this where we get a linear quotient, a quadratic quotient, and a cubic quotient. So our first one here, if we divide a cubic by a quadratic, we are going to get a linear function. So we're going to use tables to do this. And the easiest way to probably do this and to make your tables is using a graphing calculator. So what I'm going to do is I'm going to graph both these lines. I'm going to graph x cubed minus 4x squared minus 25x plus 100. And then I'm going to press the down arrow key, and I'm going to do the other one too. X squared plus x minus 20. I'm going to graph them both. And then I'm going to pull up the table. And so what I can do here is using this table, I can fill in my table. So f of x, that's the first one, and you can kind of see it in blue right here. And then the red one is the g of x. So I can just fill out my table pretty quick here. Okay. And then what I can do is I can divide those two values. So I can do 100 divided by negative 20 and just keep going down. 72 divided by negative 18. And you can do that this way, divided by negative 20. 72 divided by negative 18. And you can fill your values in for this side. So again, you're just dividing each piece, and then 0 divided by 0. So 42 divided by negative 14, 16 divided by negative 8, and some of them you may be able to do in your head. Now, 0 divided by 0, we cannot divide by 0, so that is undefined. So where this comes in handy, so the quotient of a cubic function divided by a quadratic function is linear. And a linear function is in the form h of x equals mx plus b. So if we're using finite differences, the first common difference, so the change here, how is the y or the output changing? It's changing by 1. And then the change in x is 1. That would be my slope. The y-intercept is where x is 0. And that's our answer. X minus 5. So the other way you can do this, though, knowing that a cubic divided by a quadratic is going to give me linear, I could do linear regression on this, which is probably going to be the quickest way. So we put our x's in, put our y's in, and then we're not going to do the 4. We're not going to do that one. We don't need it. And then menu 4, 1, 3. X list is x, y list is y. So 1x minus 5, that's our function. 1x minus 5 is the same as x minus 5. The other thing that we have to do, though, we have to find our zeros. And again, you can do that. There's a multitude of ways. I'm just going to graph this. X squared plus x minus 20. I'm going to find my zeros this way. So negative 5, that's 1x. And then our other x is this one right here, 4. It resulted in division by zeros. So just to show you on the graph that it's 4. Okay. So x minus 5 is our answer, where x cannot equal negative 5 and x cannot equal 4. Okay, so tables make it really easy, especially now that we know how to find. And if you don't know what the quotient would be, you can use those common differences to write, to find your function. You can use those common differences to determine what type of function it is. but also to write the function. So we're going to do the same thing now. We're dividing a cubic by a linear. So I'm going to do the same thing, and I'm going to graph both of them. So negative 12x cubed minus 119x squared minus 155x plus 700. And then my linear is negative 3x minus 20. Pull up my table and fill my values in. So we've got and then for the g of x, and then again, all we're doing is we're dividing. So 700 divided by negative 20 is a negative 35. 414 divided by negative 23 is a negative 18. Negative 182 divided by a negative 26 is a 7. Negative 1160 divided by negative 29 is a 40. And then 2592 divided by negative 32 is a positive 81. Okay, so the quotient of a cubic function divided by a linear function is quadratic. Quadratic functions, h of x equals ax squared plus bx plus c. So here, again, if we're going to do this, we would find the second common difference. So if we do, let's see, negative 18 minus a negative 35, that's going to give us a 17. 7 minus a negative 18 is going to give us a 25. 40 minus 7 gives us a 33. And then 81 minus 40 gives us a 41. So now we're going to find the second change. So 25 minus 17 gives me an 8. 33 minus 25 gives me an 8. 41 minus 33 gives me an 8. So the nice thing about these is they are going to be pretty. You're not going to have to average anything out on these. So the second common difference is 8. So the change in y is going to equal 2a. So the change in y, that's the second common difference, equals 8. So the a value would be a 4. So to find your b, a plus b equals h1 minus h of 0. So if we look at these differences that we did, 0 and 1, the change is 17. Okay, so a is a 4. We're looking for b. And the change here, okay, and so again, we said that change, that first change was 17. So if we solve this, 4 plus b equals 17. The b value is going to be 13. And then c is the y-intercept. So where x is 0, this value, that's our y-intercept. And we can write our function now. A is 4, so 4x squared. B is 13. Ooh, but I put 17. It should be 13, sorry. 13x, and then minus 35. And then we've got to find where x, so if I do negative 3x minus 20 equals 0, and I solve for x, I'm going to solve this one by hand. Add 20 to both sides. Negative 3x equals 20, divided by negative 3, divided by negative 3. X cannot equal negative 20 over 3. X cannot equal negative 20 over 3. All right, and finally, we're going to do a quartic by a linear. So I'm going to put it into the graph to pull my tables. Okay, and then 6x minus 4. Pull up my tables and then write my values down. There's what we need. Oh, but we're off just a little bit here. Let's see. Oh, why it keeps jumping. There we go. We're starting at -1 here. So for time, I'm going to pause the video and fill these values in. Okay, so again, you just divide f of x by g of x to get your h of x values. And so this one we know is going to be the quotient of a quartic function divided by a linear function is a cubic. And so a cubic function is h of x equals ax cubed plus bx squared plus cx plus d. And again, we can use finite differences here. So let me shift where you can see everything. Okay, so if we do -28 minus a -90, we get 62. 34 minus a -28 gives us, a 62 as well. 312 minus 34 gives me 278. And then 1022 minus 312 gives me a 710. So there's my first difference. Second difference, 62 minus 62 is 0. 278 minus 62 is a 216. And then 710 minus a 278 is 432. And then third common difference, 216 minus 0 is 216. 432 minus 216 is a 216. So that's my third common difference. Okay. Scoot back over here. So my third common difference is 216. For a cubic, the third change in y equals 6a, so that third change in y is 216. And that's going to equal 6a, so if we divide that by 6, a is going to equal 36. 6a plus 2b is going to equal our second change in y. So again, remember in between where x is 0 to 1 and then 1 to 2. So we want the second change there, which is going to be in between these two. So this one, which is 216 as well. So a is 36 plus 2b. And if we solve for b, our b value is going to equal 0. And then a plus b plus c equals the first change in y between x is 0 and x is 1. So 62. So a is 36, b is 0, plus c is going to equal 62. So if we solve for c, c equals 26. And then our y-intercept is a -28. So 36x cubed. We don't need to write the b value. Plus 26x minus 28. And again, you could use cubic regression here. You could use quadratic regression here. That will work on these. We divided by 6x minus 4, so we need to find our zeros. So 6x equals 4. So x equals 2/3. That's our 0. So x cannot equal 2/3.